So this is a research about online grooming that may be offensive or upsetting. Oh, sorry, this is the one. The title of the talk is Enhancing Online Grooming Detection and Backtranslation Augmentation.
Hello everyone. Actually, just a quick note that again, this is about online grooming, so it may be offensive or upsetting for you. And this is the title. So we are trying to improve the online detection of the online grooming by augmentation through the back translation. So basically nowadays internet is everywhere. So as a result, minors, kids with little cognitive development have access to, social media, messaging apps, video games, and group chat rooms. As a result, they become an easy prey for predators or child abusers. And this is the stat in the world, so you can see that it's a common thing in different cultures, different countries, and those few gray area, it doesn't mean that it doesn't happen in those countries. Basically, it is underreported in those countries because of many reasons, such as in some cultures they put the blame on the kid or the authority doesn't follow up on the report. And this is the in NLP task, as an NLP task, we can define it as learning a letter function parameters by theta. Given an input conversation, we want to just classify it into Boolean class, so normal or predatory. The positive class is predatory. And basically, the conversation should go to a vector space through another embedding method or vectorizer. We call it function G, parameter by 5. And as a result, this task ends with just an input conversation, go through a vectorizer G, and then classify it into a Boolean class using F. So, and here's the literature. So basically, the search or the research about this in this domain started late in 2012 when they, in the CLEF conference workshop, they released a benchmark dataset PAN12. And at the time, they used the traditional classifier SVM and then the Babel word kind of vectorizer. And then later, we have word2vec. Also, we have the contextual vectors by BERT or Llama. And then again, modern classifiers such as the recurrent model has been used to improve the results. But generally, all these methods lack to include the features from the conversation, plus the code line is not available, or even if it is available, it's not reproducible. And another thing is that when you look at their experiment, they report the metrics by accuracy, which is not a good metric because in this domain, the training data is highly imbalanced against the predatory conversations. Another dimension of the related work is about applying augmentation for this task. You can see that backtranslation augmentation has been used for aggression detection, but not directly for online grooming. Also, just a single word on augmentation using perturbation for online grooming. But backtranslation has been used a lot in NLP tasks such as aspect detection or query refinement in IR. And so we wanted to apply it for this task and see what would be the result. And these are the limits of the literature, as I explained. So we wanted to address these limitations using a pipeline referred to as Osprey. So first we built a reproducible benchmark code line, including all the traditional and state-of-the-art methods. And then we tried to include conversation features, and then we wanted to improve further using augmentation via back translation. So here's the link to the pipeline, Osprey at Lab, and there's a QR code, and you can see a bunch of different vectorizers and classifiers. And then we further basically studied the from social science. What are the stages of online grooming in conversation? So you can see that the predator tries to gather information about the kid, and then finally tries to obtain the trust of the kid, and then try to find the void in the real life of the kid, and tries to fill that void, and then finally start using the child. Here's an example from the training data set. On the left side, you can see that we have an online conversation. Because the predator wants to go through all these stages, usually the conversation is very long compared to the normal conversation. Also, the language pattern is different because one side is just a kid, and also the pattern of message passing is different compared to the normal one. So you can see that we observe that in online grooming conversations, there's two and only two participants, and also the time elapsed between messages is different. So then we thought that let's include these features for classification. This is the result we published in COLING 2024. Basically, including the conversational features improve the precision and recall. Also, the GRE is a better gating strategy because the online conversations are very long compared to the LSTM. But the last one is very important because for this task, recall is way more important compared to the precision, because if you have a low recall, you're going to miss a predator, so then it may end with a child abuse. So it's a severe consequence. But if you have a lower precision, worst case scenario is that we just capture the innocent person, so we can double check. And then this work, Backtranslation Augmentation. So here are some examples to showcase what backtranslation is. So basically, given a conversation, we bring in English, we bring it to a target language, such as French, Germany, or other languages, and then we bring it back to the English. And if you do this, some interesting thing happens. For instance, you end up with a new sentence or conversation that disambiguous words. For instance, in the first one, doing each other becomes having sex. And also, it automatically normalizes the text for you. Also, it includes new wordings, but considering the context. For instance, you can see that little aroused becomes $10. And then the last one is interesting for me because sometimes in a language, in a source language, you don't say something and you rely on the background knowledge. But when you bring it to another language, in that target language is not common. So the translator generated that entity, and then when you bring it back to English, it remains. So for instance here, having it with minor becomes having sex with a minor. So you can consider it shows, it brings up the new latent entity. So here's the setup for our experiment. So we pick the set of model GRU and then the comparator LSTM. We pick the best vectorizer, the set of data, and we include the time and number of authors in the conversation. And we try to augment the predatory conversation because that's the sparse class in this domain. And then these are the, research questions. So we wanted to say that whether augmentation improves the result. And then if the answer is yes, what language performs best or worst, whether the choice of translator matters or not, and whether the richness in terms of the training data for the language matters. And the data set is CAN 12, the first mentioned data set. There are some ethical issues with this data set, the way they collect the data set. So basically what they did was that they trained adults in order to act like a kid, so we refer to as decoys. And then they went online and they tried to put trap for predators. This is called entrapment, and in the US it's illegal to do that. As a result, this website, Predator Justice, this organization has been banned. You can go to the website and see they explain that. And then for the non-predatory chats, they try to just collect conversations from any company online. So Omega, it's not available now. And then another limitation is just in English, but we know that it happens in other cultures, so it's a huge demand for data sets for other cultures. But why we chose that? Because that's the only accessible data set. There are a few more, but if you contact the author, they won't release the data set. And here's the stat, so we can see that highly balanced, very few conversations are predatory. And the nicest stat is, as I said, predatory conversation, there's only two participants, and that's a very important feature. Also, if you look at the stats, you can see that the distribution of time and the number of messages in conversations are different in predatory and non-predatory languages. So it's better to include these features. In terms of the languages for augmentation, we pick these languages based on whether they are high resource or low resource for the translators, based on different language families, Western Humans, Arabic, and others. Here's the choice of commercially, a state-of-the-art translator. Also, we picked the NLB, no language defined from Meta. So it's open source, it has model card, and also the previous version of that, M2M100. These translators are interesting because they can do two-way translations for more than 100 languages. So it allows us to experiment on different languages. Again, as a reminder, recall is more important than precision in this task. As a result, in the column header, you can see that we report the F measure for the beta equal to 2 to favor recall, all against the precision F0.5 to favor precision. Also, the middle is the harmonic mean. And in the row header, you can see that augmentation with each individual language, also the merge of them based on the language family, and then the last two rows are based on their richness, and finally including all of the background versions. And in terms of showing that it improves the efficacy, so the green cell shows positive effects. So these are delta values. So before augmentation and after augmentation. And you can see that generally we have more green cell, meaning that it is improving the task per recall. At the same time, it is also improving the precision, except the M2M100 because that's not a good translator. And in general, for harmonic mean, again, majority of the cells are green, so it is effective. In terms of the efficiency, including the backtranslation augmentation makes it faster for model to converge, so we need less training epoch. The solid line, black solid line is without backtranslation, and the color lines are with backtranslation. And then in terms of, now the answer is yes. So the augmentation matters. The improvement is also in terms of which language or which translator. So in order to answer this, we have to first answer this question: what is a good backtranslation for augmentation? So here we want to have a good paraphrase of the original conversation. So we don't need that exact backtranslation one. So we want to keep the semantic context of the predatory conversation. So we use the declutter, which basically says that two sentences are in the same semantic context. And then we want to have a low blue at the same time because we want to have a new wording or new grammatical structure. And as you can see, NLB could have high declutter, low blue. As a result, it's a better translator for augmentation. In terms of individual language, we can see that Farsi or Persian as a lowest of language individually could improve the result, but when we merge that, it makes it worse. But for Germany and Islamic, as a language family of West Germanic, individually and merging of them is improving the result. So it depends on what language family you are including. And but one thing, the last one is very important. In order to have a robust performance improvement, it's better to include more languages. It's not the highest, but it is more robust. And in future work, we wanted to do early detection, meaning that we want to capture the online grooming just by watching a few phrase messages, because the assumption in these works are we have access to the entire conversation, which is not realistic, so we don't want the child to become abused. So we want to prevent it sooner. And then this is the work by my research lab at the University of Windsor, Canada. And this specific research has been done by Hamid, my master's student who graduated and found a job, couldn't make it, and then myself. And this is my last slide for people who were affected by this disaster, of course.
Thank you very much. A very sort of interesting and, how do I say, important issues that you were talking about. We have very quick question if there is anything to sort of clarify, but
yeah, hi. Really interesting work. I had a question about the vectorization. Do you vectorize the entire conversation, or is it just the messages from the brain?
Very good question. So basically, we vector each message and then we concatenate them in one experiment, or we mean them. But the concatenation is a sequence of vectors to the kernel model. We use that. That's the best.
Okay, so I guess you've experimented with different methods of
basically one hot vector and then different encoders such as PER, distal beta, and etc. Yeah. In the second paper, we actually benchmark all these different methods, and we can look at these. The best based on was distal beta, GRU, and the including the conversational features as a sequence of vectors.
Excellent.
Thank you very much. And thank you again. And we will move to the next talk. And, this is about human interest framing across cultures, a case study on climate change.